All right, it is Wednesday okay, it is not Wednesday the 20th. Where's my thing? I'm paused. We gotta hold on. We're leaving that in the video. It is Thursday the 21st. Sorry, y'all. It is Thursday the 21st. Today we're just gonna do math connections. So let's go here. First things first, talk about the dress code. We kind of already talked about this, but I just want to point this out. Wear clothes that are appropriate for school. That doesn't mean you have to agree with the dress code, because some people are like, I don't want, I just think I should. Look, it's okay if you don't agree with the dress code. It's actually totally fine if you don't, but you know what the dress code is, right? And what you need to do is abide by that. Just like we used to have a rule in here where it was like, oh, you couldn't wear hats in the classroom. I didn't think the rule was a good rule. I even got this pigeon over here wearing a hat right here, okay? But I'm just saying, like, it was a rule of school, so I just upheld it. It was okay. Now, if I really had a problem with it, then what I should have done is go respectfully talk to someone. So that is what you should do if you really have a grievance against the dress code. But if not, then abide by it. I have 3 daughters. You know how many times they've been dress coded? And 2 of them are in college. 0 times between all 3 of them. Why? Because they knew what the rule was, and they made sure that they wore clothes that were appropriate for school. Totally fine, okay? So just think of it like at a wedding. There's clothes that are appropriate for a wedding that are not, that you probably wouldn't wear to school, right? So again, appropriateness. So again, wear the appropriate schools for the appropriate school attire. I don't want to go too much further than that. You know what it is. Holla, okay? Make sure your progress report gets turned in. As long as you give it to me by tomorrow, then you can get extra credit points. All right, y'all. Peace out on that. On to the next thing. Make sure you turn in this Explore number 3. Some classes, they have as high as like 95% turn-in rate. Some classes as low as like 50% turn-in rate. I will grade this probably over the weekend. That would be my guess, because I got to get through the CERs, and that's what I started grading this morning. I was hoping to get to them yesterday, but that didn't happen. Moving on, we are having the cast practice test tomorrow, okay? So most of you guys have already done this in your other classes, so most of you guys see like right over there that, yeah, you guys make sure that your secure test browser works. Most of that has already been taken care of. We checked it weeks ago, right? And then now you guys have used it in multiple classes, totally fine. But just so you know, when you come in tomorrow, backpacks must be left on the sides or on the floor. We'll do that whole thing. We'll walk through that whole process. And then all you got to do is complete the practice test. That's all you really got to do. All you got to do is complete the practice test. It will be cool. No problems. It shouldn't be an issue to like run through it at all. So shouldn't be any issue. Just run through it. You'll get 100% for a quiz grade for this first one, okay? We're not going by score. We're just going by completion rate, okay? Just complete the whole thing. That's all you got to do. Number two, if you're not here, don't worry about it. We're just going to excuse you from it, and it won't affect your grade. All right, moving on. Okay, so hopefully this makes sense to you. You were supposed to take take notes yesterday, so hopefully you're good with the idea that this is kinetic energy, this is potential energy, this is 0.5. These M's right here are both mass, and it's both in kilograms. Hopefully you're like, oh, this V stands for what? Velocity, and velocity mathematically is equal to speed. Speed is equal to distance divided by time. Hopefully that's all cool things getting in your brain. This G right here, this stands for gravity. It's always trying to pull you down, like it's the ops, okay? But gravity, and hopefully you're understanding it's 9.8 meters per second squared. Cool. And then over here, height, right? Hopefully you know that H is for height and that it's in meters, okay? So hopefully all of that information, which is right here on this page, hopefully these things are in your brain when you're looking at these formulas. That's why I had you write it down. That's why we're going over and practicing it, verbalizing it, because you want to be able to practice as much times as you can. Okay, now as we get into the practice of this right here, let me tell you something, you really need to practice. There's one of my classes where they really, I'm gonna be honest, they were just being lazy. And when I say lazy, it's just they just didn't want to. They didn't want to get out their calculator. They did not want to do the work. They wanted to wait for someone else to do the work, okay? And I'm just telling you right now that if that's the way you are, then you're never going to get better at these things. The only way to get better is to put in effort, okay? So you got to put in effort. You got to put in the work. You know what I'm saying? I said this yesterday. Don't be upset by the results you didn't get for the work you didn't do. Then you want to, and someone said this today, I'm not good at math. And I'm like, you may not be as good as someone else, but part of the reason you're not good at math, and I told them straight up, is because right now I'm asking you to use your calculator. You're like, no. So here's a time where you could be getting better, getting some reps. Nah, I'm not going to get them. Just like Mr. Farr, today's a gym day. If I don't go to the gym, then my goal to do 10 pull-ups, right, I'm going to be further away. I'm not going to get closer. I got to get in and I got to get those reps in, okay, if I want to get better. And that's the thing about math or ELA or reading or writing, any of these things. Like, the only way to get better is to get the reps in, get the practice in. That's why Steph Curry is one of the greatest shooters that ever lived. But nobody looks at how many times he's shooting three-pointers in practice. You ain't looking at that. You ain't looking at the hours and hours and hours and hours and hours that he puts in to do the work. So you got to realize, like, in order to master something, especially if something's more difficult for you, then you got to put in more effort. But you got to want it. You got to want it, okay? So make sure as we're going through this that you guys are actually doing it. So I just have to fill in some gaps. So we did all of this yesterday in yesterday's video lesson, and we also did this over here, but I'm going to show you guys something real quick. So let me write these in here. So just again, we'll just re-practice this one more time. The M is for what? Hopefully you know it's for mass. And then the units over here is kilograms, right? And then we said that H, the H is for height, right? And then the height is in meters. And then the G is for gravity. All right, cool. And hopefully you're seeing that the gravity is in, and I'm going to put the constant because this is the gravitational constant. It's in meters per second squared, but the gravitational constant for Earth is 9.8. So just remember, as long as we're calculating things on Earth, this is what it's actually going to be. Let me move myself up out of this way just a little bit, and let me zoom in, zoom. Okay, now yesterday I showed you guys a little bit of a different way to do this, but I'm just going to walk you through this path, okay? So we underlined everything, right? And then we're like, okay, this is the mass. So we put that mass right there. Hold on, pause it, hold on. All right, so on to this. So again, potential energy is equal to mass times gravity times height. So this is the mass, and we got that from right there, the 0.48 kilograms, okay? Then this 6J, we know that that's energy, so it must be the potential energy. So I put the 6 right here as the potential energy. Then the G is for gravity, and we know we have that already. And it says, how far was the box lifted off of the shelf? So that is the height that is lifted off of the shelf. So we know that's what we're looking for. So H is what we need to solve for. So what we did here is we multiplied 0.48 times 9.8, and it came out to 4.704, right? And so we had 6 is equal to 4.704 times height. Then all we did, right, is we divided by 4.704, divided by 4.704, and then so we can get rid of it on this side. So now we have H by itself, and then now it's 6 divided by 4.704, and that is where we are going to pick up with the math and say, okay, cool. So we got the 6 divided by 7.04. Now here's the thing. It says that we need to round. You see down there? It says we need to round to the nearest tenth, okay? So as we're rounding to the nearest tenth, that's going to be right here because it's going to be 1 decimal place. So it's in between the 2 and the 7. So then that would end us up with, here, let me zoom in. Where did the mouse go? Oh, there it goes. Let me zoom in. You're going to end up with 1.2, actually the nearest tenth. Oh, my bad. Between the 2 and the 7, that means the 2 is going to round up to a 3. 1.3 meters. That's exactly how it should look, okay? So that is everything for that one. Now, this one right here, students had a little bit of a like, oh, some students thought it was this way, some students thought it was that way. So I'm going to show you a little bit of both ways. Okay, so this one right here, it says here, I'm going to move myself down. Can I move myself down? Yeah, right there, so I can move this all the way to the top. Okay, so a cart, and what number is this? I just want to make sure so you guys are good. It's number 5. Okay, cool. All right, so a 15 kilogram cart, okay, is filled with apples. It's sitting on top of a hill that is 25 meters high. The apples in the cart have a mass of 33 grams. What is the potential energy? So that's what they're asking for. Potential energy of the cart and the apples, okay? And then it says round your answer to the nearest, oh, it says whole number. All right, that's cool. So there is a cart, and the cart is 15 kilograms in mass. The apples, right, just the apples in the cart are 33 kilograms, right? So in order to get the total mass of the cart and the apples, you got to add these two together. So 15 plus 33. I'm not going to use the calculator. So 5 plus 3, right? So put the plus right there. 5 plus 3, right, is 8. And then 1 plus 3 is 48. So that's 48 kilograms. All right, cool. So I got that. I also have my height right here. This is my height. And then I already know what my gravity is. So I'm going to go potential energy is equal to, I'm going to write it out, mass times gravity times height. So that means, right, the mass is my 48 kilograms. Cool. Times the gravity, which is, remember, it's 9.8 meters per second squared, times, what is my height in this case? My height is the 21 meters, times 21 meters, okay? Now, let's go ahead and get our calculator out. Say, all right, so we'll say enter. And then I can't see because Mr. Farr needs to move out the way. So 48 times 9.8 times 21. So that is 9,878.4, but it said round to the nearest whole number. So 9,878 is going to be my number. Now you're like, how did we get there? Hopefully you saw that, hey, this 4 or less, let it rest. 4 or less, let it rest, okay? So that would be that. And since it's potential energy, we should put a J for joules, okay? Totally cool. All right, let's go ahead and go to the next one, number 6, okay? Let's read this one. A weight training ball is put on the ledge 3 meters high. The potential energy of the ball on the ledge is 200 joules. What is the mass of the ball? So that's the thing we're trying to find. Round the answer to the nearest tenth, okay? So let's just fill in what we know, okay? So the potential energy here, I'll put up here, potential energy, right? And I'll keep showing this formula. Eventually you'll just remember mass times gravity times height. Okay, so the potential energy is the 200 joules. So I'll put that in there, 200, okay, is equal to, what's the mass? The mass in this case is what we're trying to find, so I'm just going to put the M. We know what the gravity is, which is 9.8, okay, 9.8, and then we know what the height is. The height is 3 meters, so it's 3 meters. So again, we're going to multiply those two together first, okay? So 9.8 times 3. Let's get my handy-dandy calculator out here. So 9.8 times 3 is equal to 29.4, okay? Now, make sure that you're stopped and you're doing the math along with me. Use your calculator. That will help you to get better, okay? So M times 29.4. Now, what should we do now? What should we do next? What should we do next? Now we got that multiplied together. What should we do next? Hopefully you're like, oh, we just need to divide by 29.4, and that clears it off this side. But whatever you do to one side, you got to do what? That's correct. Do it to the other. So 29.4, okay? Cool. So now let's do the math. So do the math and let me know what the answer is. Again, pause the screen and you do the math. So 200 divided by, and again, you need to get these reps. So get the reps in. 29.4. So it looks like 6.8, and it says round to the nearest tenth. That's a 0 right there in the hundreds place, so we're just going with 6.8. So then that means in this case, the mass, right? Because remember, that's what we're finding. The mass is equal to 6.8 kilograms. Okay, remember that is the unit. Remember we said that over here. Mass is kilograms. Okay. Now these two problems, this is more what you see in science, especially in high school, is you'll see one problem feed right into a second problem. So you got to get that first problem correct. So let's go ahead and do a couple things, because there's a couple things to do here. So a small private plane is carrying 3 passengers. So I'm going to underline that. I'm not sure if that's important yet. The plane is 0.9 kilometers in the air. So that sounds like height. If the potential energy of the plane and its 3 passengers is 48,510,000 joules. That's it. What is the combined mass of the plane and its passengers? So we're going to have to solve for mass. That's what it looks like to me. Round the answer to the nearest tenth place. Okay. So we got a couple things. It says first I got to convert from height, from kilometers, because it's up here in kilometers, into meters. That's what I need. So because my height, again, should be in meters. That's what it says here. So I got to convert it. So we're going to scroll in a little bit, okay, and say, okay, what was our height to begin with? 0.9 kilometers. All right, cool. So hopefully this is something that you know. If not, I'm gonna tell you right now. So you can write this down. Kilo equals 1,000. So whenever you see kilo in front of something, because it's a prefix, then you know that it means 1,000 of whatever that thing is. So if it's kilometer, it's 1,000 meters. If it's kilogram, it's 1,000 grams. Okay. So in that case, we have 0 is 0.9, right? 0.9 kilometers. Okay, cool. So let's just talk about this, okay? This is how we convert it. We want to be like, okay, so we start with 0.9 kilometers, okay? That's totally fine, over 1. And how we're going to convert is this. We want whatever we're converting to be on top of the conversion factor. So we want to convert to meters. So 1,000 meters. And for every 1,000 meters, there is 1 kilometer, okay? So 1 kilometer is equal to 1,000 meters. Then this is all you're going to do. The kilometers cancel. They're going to cancel right there. And then now it's 0.9 times 1,000. So we just got to put that in the calculator. You do the math. You let me know. And then I'm going to keep going. So then I'm going to press enter right there. Say 0.9 times 1,000, okay, times 1,000 is equal to 900. So 900 meters, okay, 900 meters. 900 meters. Now we have our proper height. So let's just, proper height, we're going to put everything over here, and let's go ahead and get all this information. This one's going to be kind of a long one, right? So then, again, it says we're finding what is the, let's see, what is the mass? So we already know that means they gave us the potential energy. So we're going to say potential energy is equal to mass times gravity times height. So the potential energy is this 48 million, right? So I'm going to have to go over here, 48 million. We're going to be putting a lot in the calculator, right? That is our actual potential energy. We're going to find the mass. So we're going to put that down there times in our gravity, gravitational constant of Earth, 9.8. times 900 meters, okay? And again, just like we did before, we're going to multiply these two together, okay? We're going to multiply these two together. So let's see what we get. Let's see what we get. Okay, because this is going to be kind of a crazy one. Oh, no, don't tell me my, what do you call it, is not going to, oh, I can't get it. I don't know where it's at. All right, so hold on. All right, cool. Ooh, got my number in there. So this is what I got to do. 9.8 times 900. That gives me 8,820, okay? So let's just go ahead and bring all this down. Is this, so we got the 4, 8, because this part just is going to drop down because we haven't done anything with it just yet. Okay. Okay. Times, hold on. I forgot how much it was. 8,820. Okay. Cool. I got it. 8,820. Okay. So now I'm just going to divide by 8,820. Okay. Divided by 8,820. Cool. So we're okay, cool. And then we're gonna go ahead and get this in and say Bladow. And then so we gotta go. Oh, we gotta say oops. Let's go ahead and delete that. We'll say enter. Boom. And now we got the 48. 5, 10, and then my 3 zeros. That's my 48 million. Let me make sure we got. Yeah, I got my 48 million. And then we're gonna say divided by 8,820. That ends us up with 5,500. So that means the kilograms is 5,500, right? So that use this formula to solve for the mass of the plane and the passenger. So 5,500 kilograms. That again is the mass of the plane and the passengers together. Okay, so them together. Let me just double check. Yep, 5,500. That's exactly what it is. All right, now, so we were able to get that answer, right? And I'm just gonna put this M right here. M is equal to. So that's the mass right there. Now, here's where we got to use some logic. Okay, we got to use some logic in order to figure this out. So for number 8, if the plane from question 7 has a mass of 5,000, and this is how a lot of these problems work. Like it's one information or other has 5,275, and all 3 passengers have the same mass. What is the mass of each passenger? So this is what what you got to think about. This is just the mass of the plane. Up here is the mass of the plane and the passengers. So the difference between these two is the mass of the passengers, because we're going to subtract out the mass of the plane from the mass of the passengers and the plane. So that's going to be 5,500, right? 5,500 minus 5,275 is equal to. So now we gotta do a little bit of math. Mr. Farr is like, I can kind of do it in my head, but if you can't, it's totally fine. So we're gonna take this 5,500, right? Say enter, and then we're gonna take 5,500, and we're gonna subtract out 5,275. Oh, I actually didn't put enough zeros in there. That's why I like using the decimals calculator. So that means 225 pounds is, or 225 kilograms, 225 kilograms, right? That is the mass of the 3 passengers, okay? Cool. Now, if all 3 passengers have the same mass, what is the mass of each passenger? So there's 3 passengers, and if this is the total mass right here, this right here is the total mass of all the passengers, then in order to get the mass of each one, we just need to divide by 3, which is equal to, let's see, because we got to do some more math. I know people are like, oh my gosh, Mr. Farr, are we almost done? Yes, actually, we're almost done. Actually, legit, we're like almost there. So then we'll say enter, and then say 225 divided by 3 means each passenger has a mass of 75. So each passenger's mass is 75 kilograms. Now that was some logic going from 1 to 1 and saying, well, this is the mass of the passengers and the plane. Okay, if we subtract out the mass of just the plane, then we have the mass of the passengers left. Divide that by 3, since they said there's 3 passengers, and then we get 75 kilograms. All right, you've been with me on a long journey. I want to say thank you for having endurance. Thank you for using your calculator. And if you didn't use your calculator, I'm being 100% honest. You need those reps. You need those reps. That's how you're gonna build your mathematical strength, right? Is by getting them reps in. All right, y'all. Love y'all. Peace.